So now we are ready and you can start now.
Okay, yeah.
And
So, yeah, I hope you can see my screen. So,
yes,
la
please.
yes. So, last time, I think we stopped at the natural selection page, and we are moving on to finish up the chemistry part of BEC science. So, let's start with this question. Which of the following statements accurately explains the positions of calcium and magnesium in the periodic table? They all have the same what, do you think? You can compare these two texts. This one is calcium, and this bottom one is magnesium. So, do they have the same proton number? Is that right? The proton number can be the same as the atomic number here. So calcium has 20 protons and magnesium has 12 protons. So it is not A. And do you know what valence electrons are? So valence electrons means the electrons, these tiny balls that are on the outermost shell. So on the outermost shell of calcium, there are two electrons. And then on the outermost shell of magnesium, there's also two electrons. Can you see this? So can you see that both calcium and magnesium have the same valence electrons? So two here, there is two, and then in magnesium, one, two, there's also two. So that is why they have the same electrons. They don't have the same number of shells because calcium has one shell, two shell, three, four shells. Magnesium only has three shells. And atomic structure is different as well because they have different numbers of electrons and protons. Okay. So that is why the answer is B. But we can see here, everything summarized. So yeah, like I said, atomic number of calcium is 20. And atomic number equals proton number. And that also equals the number of electrons. So they're different. They have different atomic numbers, so their proton and electron numbers are different. And like we've said, valence electrons are number of electrons on the outermost shell. So we saw that they have the same number of valence electrons. And a stable atom has a structure of First shell having 2 electrons, second shell having 8 electrons, and third shell having 8 electrons. Um, these are called stable atoms, or on the periodic table, they're mostly called the noble gases. But let's see the periodic table over here to get a clearer sense. So here is the periodic table elements that are named from 1 to 20. And it is good to memorize the atomic numbers, the atoms for atomic numbers 1 through 20. But it is pretty simple if you look at it and maybe memorize them. But for concepts, like we've said, the first shell corresponds to the first row. So here, you can see that hydrogen and helium are on the same row. That means both atoms have only one electron shell. Hydrogen has 1 proton, 1 electron. Helium has two protons and 2 electrons. So that is the first shell that holds up to 2 electrons, 2 valence electrons. And then the second shell can hold up to 8 valent. So you can see from lithium all the way to neon, it can hold up to 8 more valence electrons. And the third shell can also hold up to 8 valence electrons because you can see that elements are increasing up to 8 at a time for the second and the third row. So yeah, let's look at this picture. So summarizing, we compared calcium and magnesium. If we look at these two, you can see that the innermost shell has 2 electrons. It has 2, and then the second shell has 8. If you count all these smaller balls of electrons, and there are 8 electrons on the second shell. On the third shell, it also has 8 electrons. So all of these are very, very stable. So it has the 2-8-8 structure. And then there are 2 left, and these 2 are called the valence electrons, what are on the outermost shell. And similarly for magnesium, there's 2 inside the first shell that is fixed, 8 in the second shell, and this makes it stable. So 2-8. And then finally, we only used up to 10 electrons, right? We have 2 remaining electrons because magnesium has atomic number of 12, needs 2 more electrons. So the 2 are on the valence shell, the outermost shell. So that is why these 2 are called the valence electrons. Can you see this? They're equal. 2 over here, 2 over on the right. So does everyone understand this concept? Do you have any questions so far? Any questions or is everything clear?
Yeah.
Okay. Yeah, I hope everything is clear then. And
Yeah.
okay. And I will send you the slideshow later after this class, but be sure to memorize this table at least a little bit. You should know like one, the first like element on the periodic table is hydrogen, and second is helium, third down the row is lithium, and then you can memorize maybe the numbers and then the number of atoms, what atom that number corresponds to. And then you should also maybe try to draw the atoms like this with the stable and the valence electron configuration. How are they shaped? So, yeah, that's good practice for chemistry. So, now let's look at this question. So, the chemical formula for iron 2 sulfide is what do you think? Yeah, so this might be a little bit difficult because it's a new concept. So you're forming these words into a formula, into a formula. So the answer here, let me explain this here. So iron 2, what does iron 2 mean? So iron 2 means it is an ion that can lose two electrons. When it's in ion form, then this particular iron loses two electrons. That is why it's called iron 2. So it results in Fe2 plus. I haven't covered what ions are, but ions are when you lose or gain electrons. So if you have a positive charge, that means you have lost electrons. If you have negative charge on the atom, that means it has gained electrons. For the purpose of this test, though, um, you should just know that ions can be positive or negative depending on the electrons. Sulfide ion is an ion that forms from the element sulfur, S. So sulfur ion forms S2 minus. So the sulfur atom gains two electrons to form an ion. And this particular number, this 2 minus, well, you can look at the periodic table and determine like how many numbers of electrons you need to form the 288 structure. Always remember, can everyone look at this? 288 structure, or you can continue on to 2888 and etc. But this is the stable form. This is very, very stable. Ions form because they want to make their electron shells stable. So sulfur has an electron configuration of 286. This is not 288, right? So sulfur wants to have, it wants to gain two more electrons to become stable. So can everyone see this? So if you add 2 to the 6, then it becomes 8. And you can always find the number of ions by just looking at the atomic number, right? And then organizing into the 288 structure, into different shells. So that's why it's important to memorize the atomic number and the atoms, right? That's why I told all of you to maybe try to memorize the atomic numbers and the atoms from 1 to 20. And you can look at this after class, but it is good practice and it'll let you answer a lot of questions on BEC chemistry part. Okay, moving on. So because sulfur atom forms S2 minus, and we had Fe2 minus ion 2. Sorry, 2 plus ion. So by combining this ionic bonds, they form a bond together because it's positive and negative charge, right? They attract. So sulfur iron had 2 plus charge and sulfur had 2 minus charge. If you add the charges together, they become 0. And a molecule has to have 0 charge. That is why it forms a structure, this chemical formula of FeS. Okay, this was a very long and very difficult concept, especially if you're new to learning chemistry. But I hope you're able to understand a little bit, especially like how you solve the problems. Um, if let's say we had iron 1 instead, so just as a quick example, if we had iron 1, if we had iron 1 instead, this would form Fe1 plus. It'll just have 1 plus. And if you want to form a bond with sulfur, it needs to have 2 iron 1s, right? Because it only has positive 1. So 1 minus 2 is negative 1. It's not 0. That's why you want to have 2 minus 2 by adding 2 iron 1s. But this case, it was simpler because we had already iron 2. So the answer is C for this question, FeS. That is the chemical formula that forms with iron ion and the sulfide ion. Yeah, this was really long, but does anyone have a question so far? Okay, let me actually show you another case on the next slide. If this were to be if iron 3 Okay, let me have a new question. If iron 3 forms with sulfur ion, what will be the chemical formula, you think? This is a little applied question. Okay, can we start with this one? What is the ion form for iron 3? What is the ion? What is the ion for iron 3? Any- So, yeah, it will be Fe how many plus? Yes, that's right. Fe3 plus because it's iron 3. What about sulfur again? What is the ion? We did this earlier. It'll be S what minus? Yeah, right. It's S2 minus. So how do we form a bond between these two? They're coming together. Do you think this is FES? Yeah, go ahead. Did you say Fe1S or oh, let's see if this is correct. Let's see if you did it correct. So Fe1 is just one iron. So it has a charge of 3, positive 3, plus 3. But S has negative 2. This equals 1, right? This is not 0, right? The formula has to equal 0. This does not equal 0. So do you want to try again? Or because Fe1S does not form a stable form. So I can help you walk you through this if you want. You can notice that it has to be 3 something times 3. Let's call it x, and then minus like something 2 equals 0. The simplest way is to have x be 2, so 6 minus 6 should be 0, right? That is the simplest form that we can make. So what is x and y here? What would be x? Because x times 3 equals 6. So
It will be 2 times 3.
Yes, right. So it'll be 2 times 3. So that's why iron has Fe2. What about sulfur? S. What is Y here?
3 times.
Yes, that's right. 3. 3 times. Nice. So the chemical formula for iron 3 plus sulfur is Fe2S3. Okay. Um, because yeah, this is how we solve the question of forming, like if a question asks what like what is the chemical formula for this? If it asks that, then you should be able to answer with this process. Yeah. And then let's have another actual example with aluminum. One more example, and we can move on. I'll move through this quickly. So let's look at iron 3 plus aluminum. Let's see. I'm sorry, let's say aluminum plus sulfur. Okay. Let's form a chemical formula for aluminum and sulfur. So, what is the atomic number for aluminum? Let's look back. Let's look back. Okay. Aluminum
10.
atomic number, yeah, is 13. Can you see this?
Yeah.
Aluminum, Al, has atomic number of 13. So here, let's go back. Here, because aluminum had 13 13 electrons, then it forms a 2, 8, and then what is the valence electron of aluminum, do you think? What goes here?
I don't know what's wrong.
So aluminum has 13 electrons, right? And if you have a 10 in the inner shells where it is stable, it forms 10 in the inside, then how many are left? How many valence electrons are left? We have 3, right?
I
Yes, can you see this? It forms a structure of 283. So let me draw this quickly too. Aluminum. So please watch me as I draw this. So 2 on the inner shell, 2, 1, 2, So 2 electrons in the inner shell. 8 on the second one. So if I can draw like 1, 2, 3, 4, 5, 6, 7, 8. 8 on the second and 3 on the outermost shell. 1, 2, 3. It looks like this. That looks like an aluminum. So that's why an ion forms when it wants to get rid of the valence electrons, the 3 electrons on the outside. It wants to be like this because it is stable. 2, 8 is stable. So aluminum, therefore, loses 3 electrons. They lose 3 electrons and form Al3 plus. And then for sulfur, we looked at, again, it's the same sulfur. It forms a S2 minus because it gains 2 electrons to form a stable form. Okay. And if you combine these two, it is the same, right? What is the chemical formula for aluminum and sulfur? It's the same case, right? With the iron. So it'll be Al3, sorry, Al2, S3. So we looked at a lot of different examples. So yeah, we looked at a lot of examples of forming chemical formulas with different atoms. And does everyone understand this concept? And do you have any questions before I move on?
No, that is for sure.
Okay. So I think some of these are just good to memorize, right? Good to memorize ions because you don't have time to think about the atomic numbers, and it's a lot of stress to memorize all that. So I will just prioritize in memorizing certain ions. So very simply, you can have K plus, potassium. K is called potassium. Potassium has an ion of +1. Another common one is calcium. Calcium has 2 plus. Another common um ion is Cl minus, and like we looked at S2 minus, or for oxygen, O2 minus 2. And a common like molecular ion, there are also molecular ions, is OH minus or hydroxide ions. Or you can maybe just look, I think calcium and potassium, those are the sort of main two that are on the first 20 periodic table. You can see some others appearing too. If we look at, yeah, lithium, but I don't think lithium appears too much, but still, oh, a lithium and sodium. We can see sodium too. Sodium appears a lot. So Na plus. but I don't think lithium appears a lot. But these are some ions that maybe you should prioritize in memorizing. So can everyone write this down? If you want to, if you have a pen. And then also H plus. Sorry about that. You don't have to write this top part, but write the ions. Yeah, please write this ions just as your reference.
Are you working? Entiendo. Entiendo. How you done? So what did you get? All right.
Yeah, please
Genesis,
let me know if you're finished writing. Um, yeah, if you
yes.
memorize these ions, it'll be good because on the test, you know which atom has which ion, and we looked at how we can form chemical formulas of ionic bonds together. So use those methods with these ions. Okay.
Please, we are done.
Okay. If you're done, we can move on. Yeah. So let's look at a mixture problem. Moving on to topic of mixture. Classify a mixture of each of the following pairs of substances as either homogeneous or heterogeneous. Homogeneous means it is a mixture that is uniform composition throughout, when the components are evenly mixed together. Heterogeneous mixture, on the other hand, has non-uniform composition. That means that the components are not evenly mixed and can be separated. So what do you think, what type of combination do you think oil and water is? It is homogeneous or heterogeneous? So does oil and water mix well together?
No.
No, right? Yeah. So that's why it is a heterogeneous. Hetero.
Yeah.
Yes, right? Heterogeneous. Okay. What about salt and water?
Homogeneous.
Yeah, great job. It's homogeneous because they mix well together.
Yeah.
What about ethanol and water? Yes. So ethanol is a type of alcohol.
Apple.
And if you
Apple.
mix alcohol with water, it mixes well, right?
Yeah.
Yes, so it'll be a homogeneous mixture. So,
Apple.
yeah, right. I listed a
Mango.
few examples here. Salt water is homogeneous. Sugar water and air is also homogeneous. Air is an important part because if we look at our air, it has a lot of components. Like it does not just contain oxygen. It contains nitrogen, um, and then oxygen, like different types of carbon dioxide form as a molecule, CO2, and then all of other molecules that are atoms of air molecules that are small. So they're comprised and combined evenly. So they're evenly mixed. So that is why our common air that we breathe is a homogeneous. Like that. The next examples of heterogeneous mixture are things like sand and water. Sand and water don't mix together. Well, oil and water and soil. If you look at soil, it has a lot of components, a lot of parts that are not mixed together well. That's why soil is a heterogeneous mixture. Okay. And talking a little bit more about air, the nitrogen is actually the solvent. So solvent means the component that has the most. So smaller parts are called solutes. In a mixture, I think um yeah, before I move on. So solutes are what is contained in the solvent. So the air is like high percentage of nitrogen. Think like 70 or something percent around of nitrogen. It has a lot of nitrogen. That is why nitrogen is the solvent. What is dissolved in this nitrogen sort of solution, if you think about it, are things like oxygen, carbon dioxide, all these other types of air molecules, which is less than the amount of nitrogen. That's why it's called the solutes. If you look at salt water and sugar water, water is the solvent. So in both cases, water is the solvent, and the sugar and the salt are the solutes, what is being dissolved, usually in a smaller amount. That is how you can classify a homogeneous mixture, what is being mixed. Yeah, I hope that makes sense. But I have a
Yeah.
better diagram here. So you can think about any sort of matter, any matter as being mixtures or pure substances. Pure substances are things like atoms, the elements themselves, the pure elements or pure compounds. Pure elements like oxygen, hydrogen, and potassium are elements. They are pure substances. Pure compounds include water, chloride, carbon dioxide. All of those are compounds that are not mixed together. But mixture, we have seen two different types, homogeneous and heterogeneous. So yeah, we've already talked about this. So it's pretty clear the difference between the mixtures. And I just wanted you to know that there are different ways of categorizing pure substance versus mixture. Okay, so now we can move on. So let's look at this question. This figure 1D, this on the left, this figure, is an illustration of experimental setups A and B used to demonstrate a scientific principle. Let's study the figure carefully and answer this question here. So number one, name the scientific principle being demonstrated in both A and B. I wrote down the answer here because um, just to show what is happening here. So what are people, well, scientists A and B doing? They seem to be separating something, right? Here's
Yes.
like a certain mixture. Yes, they're separating. And then they're evaporating something. And then they're separating the water out and leaving something here. And then on the right, B, what is B doing? B is pulling a magnet and pulling maybe the iron or something magnetic out of this solution, out of this mixture. Both cases, that is why both cases are doing separation of mixture. Yeah, I hope you understand this point. They're both separating the mixture. Yeah, nice. Let's look at, yeah, this specific separation method on the left, A is doing what is called distillation. This is the process. So distillation, what it is that it separates a mixture of liquids. It is a mixture of liquids based on the boiling points. So liquids all have different boiling points. They have different temperatures in which they evaporate. So whatever liquid has the lower boiling point evaporates first and then condenses over here. It goes up like this and then down here, condenses into that liquid that is being evaporated. And what is left here is whatever had a higher boiling point, whatever had more resistance to breaking the bonds to form a gas molecule.
Apple.
Okay. And on the right, what is this process? It's magnetization. So, like its name says, magnetization uses magnetic attraction from the magnets to pull magnetic substances out. That is a way to separate. Usually like a heterogeneous um, mixture, but like a soil. Soil, you would pull out the magnetic particles like irons that are inside. You wouldn't really do this with like a homogeneous mixture, mostly. But these are the different separation mixture that they do. Okay, let's move on. Okay, I will be skipping over this like quickly because I want to move on as well. But number two basically asks what is two and what is four? What is two and what is sorry. 6. Or, yeah, I think this one is labeled a little differently, but this is supposed to be 6. Okay. So number 2 here, this is called a condenser. Do you see why it is a condenser? Because gas, like I said, cools down as it goes through this pipe, sort of. This pipe cooling down is a process. The vapor cooling down and forming a liquid is a process called condensation. That's why number 2 is a condenser. Okay, number 6, this one, we can all answer that is a magnet, that is a bar magnet. That attracts magnetic components of the mixture that separates it. Okay, those 2 are clear. Next, name any 2 types of materials that could be present in each of the setups labeled 3 and 7. Let's look at 3 and 7. Over here, this is 3. 7, this is here. If you notice, number 3, that is the component that has been boiled off first, right? Number 3's boiling point, we call it BP, is lower than that of 4. That is why it evaporated first. So just pick anything that has low boiling point, right? Things like water and alcohol is a good example. Alcohol is a great example because alcohol has very low boiling point. You can say number 3 is alcohol. That's a great example. Next, number 7. This one, what is left here? After the magnetic component has been pulled out, it can really be anything non-magnetic. It just has to be non-magnetic. So things like sulfur powder, not iron filling. Okay, let me remove that. Check. Number 7 can be sulfur powder or things like sand, even sand, soil residue, etc. There can be many more. Okay. Anything non-magnetic that has been left out. Okay. Yeah. Let's see how many are left. Okay, only a few left, and then we can move on to agriculture. All right. So, which of the following natural cycles directly involves the sun? So, so carbon cycle, there's water cycle and the nitrogen cycle. So, yeah, I accidentally put the answer here, but let's look at the reason why it is B. So, why is it B, 1 and 2 only? Let's walk through each cycle a little carefully, and we can understand why nitrogen cycle does not need a sun. It doesn't need a sun. But carbon and water cycle needs a sun. Well, first of all, carbon cycle is the movement of carbons. You can think about carbon moving around in our atmosphere, in our environment, through our soil, through the ground, to the air, and then through plants and animals, it moves through. Similarly with nitrogen, it's about how nitrogens move. And then similarly with water, it is about how waters move. Okay, let's look at the carbon cycle. more clearly. This is the process of carbon cycle. So, there's a lot of carbon dioxide in the air, a lot of CO2 floating around, a lot of CO2. CO2, CO2. And then the CO2, the carbon dioxide, is then taken into plants. Do you remember about photosynthesis? Yeah, photosynthesis is the process that plants take in carbon dioxide and water to produce oxygen and sugar. So plants take in carbon dioxide during photosynthesis. So now the plants have the carbon, but when plants die, then they, like the dead organism, all the dead organisms and waste products, the carbons that are in those are in the ground now. The carbons are then transported to the ground. And then it can also be transferred back to the air. Carbon dioxide or any sort of carbon can then be pulled back to the air by things like using animal respiration produces carbon dioxide. Things like auto and factory emissions cause a lot of carbon dioxide into the air. And then that carbon dioxide is used again by plants, right? Plants use photosynthesis to take in carbon dioxide from the air, so it is like a cycle, right? The plants take in carbon dioxide, they die, and then they are rooted to the ground. And then from the ground, things like fossil fuels gather, and then we use those fuels in the factories to produce a lot of carbon dioxides into the air, and the cycle goes on and on. That is the carbon cycle. And it needs sunlight, right? Because plants require photosynthesis, and during photosynthesis, plants need sunlight. Okay. Yeah, I hope this is clear for everyone. So,
Yes.
yeah, I will be moving on to the next slide about nitrogen cycle. Nitrogen cycle, it's a little bit more complicated, but I'll not explain, I'll not be explaining it in detail. Just know that there are different processes for how nitrogen gets transferred. Main thing is that nitrogen does not need sunlight. What it does is it goes a lot of process of fixations and ammonifications. So things like from cow dungs or any dead organisms, it goes through ammonification to form this ammonia molecule, NH4. So this contains nitrogen, right? The ground now contains nitrogen. And it goes through a lot of fixations, and then it results in nitrogen dioxides, and it goes through many different processes of nitrifications by bacteria. And also, there are nitrogen fixing bacteria that are involved. So it goes through a lot of these processes that can go back into the atmosphere with N2, and then that nitrogen as an air form can be transferred back to the soil. But the main part is that it does not need sunlight. No sun required. It does not need a sun. Now let's look at the water cycle. The water cycle is, the most simple but important cycle. So there are three steps involved to the water cycle. There is evaporation from the surface water. There's condensation, like the water vapors forming clouds, and then precipitation finally. As water vapor, as they condense, they get heavy and they fall back as rain. If you looked at rain before, then that is a result of precipitation. And we need sunlight. We need the sun because it helps with evaporation. So sun helps the surface water evaporate to form water vapors to cloud. That helps propagate and help um go through the cycle better. Okay. And things like land, oceans, and atmosphere are involved. And surface waters are things like, rivers, lake, and streams. All of those are surface waters. But remember the main steps of evaporation first into water vapor, condensation into clouds, and then precipitation of water back to Earth. So it has a cycle. It's circular. That's why it's called the water cycle. Okay. I think, yeah, these are the two last slides for science. So state two practices that destroy water bodies. So
Allowing domestic animals drink directly from water bodies.
Oh, yeah. You listed a few, and yeah, I listed a couple as well. First, it's like dumping waste, like we would consider. Dumping waste can harm water bodies. Chemical spills can also harm waters. Fertilizer and pesticides can also harm water, and oil spills, especially in the ocean, is a problem now. Okay, next question. Give two methods of conserving water bodies. How can we conserve water?
And planting of trees around.
Oh, yeah, I think you said planting trees. Um, that
Yes.
can, yeah, that can help in blocking the waters, maybe preventing runoffs and preventing, water bodies going out of control. Yeah, that is definitely one way. And I did list some other ways, things like proper waste disposal. You don't want to um throw your trash away in the ocean or in the water. You can avoid the chemical dumpings. Yeah, plant more trees, like you said, and then use fewer pesticides. Yeah, number three. State three effects of dumping waste materials into water bodies. What can happen by dumping trash into the water? So there are effects, things like it can pollute drinking water, it can reduce oxygen in water, and kill a lot of animals or parts in the ecosystem, like fish and other sea animals. It can introduce things like germs and disease into the water as well because it contaminates it. So these are three examples of very bad effects caused by dumping waste into the water. So yeah. Last question for the science slide. Let's look at this one. A substance that could be used in large-scale treatments of domestic water is what, do you think? What can be used as a treatment of water?
Chlorine. D.
Yes. Yeah, great job. That's right. It's chlorine because it does help kill harmful germs. And chlorine water treatment is a common process of, adding chlorine to the water to kill harmful germs like bacteria and parasites. And it is the most common method used to make water drinking safe. So remember, chlorine water treatments is a very safe way to treat water. Okay. So that was with the BEC science part. And we can move now on to the agriculture part, which is this next slide. Okay, we can look at some parts of the agriculture today, and if we don't finish it, we can continue next time. So, yeah, let's talk about environment and agriculture. Let's start off with this question regarding agriculture. The following factors hinder vegetable production in Ghana except what? Except. So, what is something that does not hinder? So, what hinder means like stopping, blocking, preventing. You can think of preventing vegetable production. This is except. Is it the high cost of agricultural chemicals? That would hinder vegetable production, right? So it is not A. Is it lack of market for farm produce? That would hinder, right? So it's not except. That would hinder. What about irregular rainfall patterns? Irregular rainfall that would not allow the plants to grow well. So it is not C. Availability of sunlight is the answer because it does not really hinder vegetable production. It actually benefits from sunlight, right? So if there's a lot of sunlight, then it would actually help with vegetable production and not hinder it. So that is why it's a good thing. The answer is D. Availability of sunlight. Okay. Yeah, sunlight is a benefit and it's not a problem. All of these rest of the options, A, B, and C, are problems that are being faced. But sunlight is a benefit. Okay, let's look at this question. Which of the following nursery beds is suitable for a flood-prone area? A flood-prone area means a flood risk area where there's a lot of flood. let me just water washing down. What is suitable there? Okay. So, yeah, flood. If you have a flood flowing down, water is flowing down. If you have a plant that is down here, then they would all die, right? They would all die. So, what is suitable for this is that you need to have it up above the ground, right? Even if it floods, if you have a plant that is on top of here, it'll be safe, right? It'll be very, very safe. And what option does it do that? A raised bed does, right? Like this one is a raised bed. And even this one, it has a little bit raised, right? It's a little bit of height to it. That is why the raised bed is the best and suitable option for flood-prone areas, because water will not flood and reach the plants if you raise the platform beds or the nursery beds. Okay, so I have a couple examples. Yeah, the raised nursery bed are raised around 15 centimeters above the ground. So things like this on the left. The important part about raised beds are that they improve drainage and they warm up quickly and they help the seedlings not get flushed away by the flood. That is their benefit. And we've talked about nursery beds, started to talk about nursery beds a little bit. But nursery bed is a place where young plants or seedlings are raised before they are moved to a farm or a garden. So nursery beds, whenever you hear nursery beds, they're for very, very small and young plants, like seedlings or even seeds that are planted. Then they can be moved on to bigger farms if they grow enough. And, here are other nursery bed options. There are things like sunken beds that lower the ground level in dry places, and flatbeds, these typical flatbeds that are at the same level as the ground under normal conditions. Okay, so let's look at this question. What is one benefit of technology to industrialization? Industrialization is basically um like the process and what we're facing now. How many industries are being made, what progress or what machineries are being made, and things like that. What is the benefit of that? Yeah. If you said C, then that is correct. Yeah, good job. Because the rest of these options, like I've pointed out, are pretty much disadvantages. Let's see. Increase in cost production, that's definitely a disadvantage, not a benefit. Reduction in skillful labor results in job loss, so that's why it's a disadvantage. And pollution is definitely a negative effect. Provision of machinery, what does that mean? Provision of machinery means supplying machines for use in industries, farming, constructions, and other areas. So it can save a lot of time and increase production in certain things, especially in agriculture. So that is the benefit to industrialization. Okay. Now let's look at this question. Nitrogen deficiency in soils causes what, do you think? Oh, yeah. If you, I heard you said B, that's correct. Yeah, great job. Because you can see in these pictures, I've listed a couple of cues, hints. Um, you can see the leaves turning yellow in the pictures. And that yellowing of the leaves are caused by nitrogen deficiency in soil. When the plants need a lot of nitrogen too. But without proper nitrogen in the soil, it causes the yellowing of the leaves. Yeah, specifically, this process is called chlorosis, where leaves turn yellow because nitrogen is essential for chlorophyll production. And chlorophylls are what makes plants green. They're the pigments, the green pigments that are in the plants. That's why without nitrogen, some parts of the leaves turn yellow. What we can do to compensate for that is use nitrogen-rich fertilizers. So a compost is a great natural fertilizer. It contains natural rotten organic wastes that turns into dark soil-like material. Um, these organic wastes can then be, turned for use for plants because they're very rich in nitrogen. And there are also things like manure, like animal waste. There are also blood meals, urea. All of these are examples of nitrogen-rich fertilizers, which can be used for plants to keep a healthy plant. Okay, can anyone answer this question now? A poultry farmer observed that the layers were producing thin-shelled eggs. Use this information to answer the question below. The defect identified, the thin-shelled eggs, are mostly caused by deficiency in what, do you think? Yeah, if you said D, then that is correct. It is calcium because calcium deficiency is the most common cause of thin-shelled eggs because eggshell is comprised over 90% calcium. And I think, can you wait for like 3 minutes if that is okay? I need to step aside for 3 minutes. And I'll be back in just a few minutes. Okay.
Okay. Hey, we can't say it. That's it.
Okay, yeah, sorry, I'm back now. Yeah. Okay. So, yeah, we were talking about the calcium deficiency.
Yeah.
So, yeah. So, calcium deficiency can lead to this thin-shelled eggs because eggshell is a lot of calcium, 90%. That's why it can lead to this deficiency. A follow-up question is what ingredient can be added to feed the correct defect? What can be used to prevent the thin-shelled egg?
D.
Yeah, right. It's the oyster shell meal, right? Because oyster shell meal is rich in calcium, and things like other ones like maize is rich in carbohydrates. Soybean meal is rich in protein. Cowpea is also rich in protein. But thin eggshell is caused by a lack of calcium. So we need a lot of calcium, which is in oyster shell meal. Okay. Let's move on to this soil part now. Um, and then we'll continue next time as well. So, when equal amount of water is poured on dry soil samples, the increase in weight per unit amount of soil would be the highest in what, do you think? What would have the most weight due to water? Yeah, an increase in weight. Yeah, what do you think? In other words, this question is asking what absorbs water the most? What does not water let through the most? Gravel it has a lot of big rocks, right? Big rocks mixed in between. Water will just go right through, pass through. So it's not, yeah. Did you say B? Oh, yeah. If you said B, then that is correct. Yeah. And that's because here, clay soil, on the other hand, is very compact. You'll see in the next slide that clay soil has a lot of small particles that are together, close together, tightly packed. So they can absorb water really well. And the weight, therefore, will increase the most when water is poured. Sandy soil, it's still very porous, meaning that it has a lot of um, space in between. Sand, you might think sand grains are small, but compared to like clay soil, clay particles, the sand particles are really, really large in comparison. And loamy soil, it's like a combination of sand, silt, and clay. It is the best soil for farming because it contains rich minerals, but it is not as compact as purely clay soil. Okay, so let's look at different types of soils, starting with clay soil. So clay soil contains more than 30% of very small and tightly packed clay particles. It has a smooth, sticky texture when wet, and it becomes very hard when dry. And clay soils have high water holding capacity, meaning that it can hold up to a lot of water. So while it is pretty difficult, challenging to cultivate, clay soil has a lot of benefits, like including high nutrients and water retention. So you can see on the left, this is a wet clay. This one has a lot of water contained inside. But when clays get dry, it gets very, very dry like this. It gets very hard and very fragile. And again, clay soil has this very high water capacity because the particles are small, very small, and very tightly packed together. And that's different from other types of soils. For example, if we look at sand soil, like here, is a type of soil characterized by large particles. Well, compared to like clay, it is very large particle. It is excellent for drainage, for draining water to pass through, but it has very poor nutrients and very poor water retention. And sand has a coarse texture, meaning it's like a rough texture, and it contains more than 70% of sand particles. Next is the silt soil. It's a new type of soil that I've introduced. This silt soil is a type of fine soil made up of small particles of rocks and minerals, all of them mixed together. It is a fertile, like a medium texture soil, and it can be pretty smooth and silky, the texture. And the silt particles are larger than sand, but they're smaller than clay. Sorry. So the silt particles, sorry, are smaller smaller than sand and larger than clay because clay particles are really small. So it is larger than clay and smaller than sand. So it has like a balance of water retention and drainage. It's like in the middle, it's a middle ground. Finally, there's a loamy soil because loamy soil is like a balanced mixture. It contains all of the above. Sand, silt, and clay. All of them are in the loamy soil. And it offers excellent drainage because of the sand and other larger particles. It lets water drain out. It has a good aeration, like letting air through, and it has great water and nutrient retention because of the property of the clay. And, silt also has a lot of good minerals, and all of them combined forms this loamy soil, which is best soil for farming. It has the best components that make the plants grow the best. It can let water through. It has excellent nutrients. It can hold up to water. Has abundant organic matter too. So that was loamy soil and these three other types of soils. So yeah, compared to clay soils, the way to improve clay soils, I haven't talked about this, sorry, this part. Way to improve clay soils. You can add organic matter like compost, manure, or even leaves, or the process of mulching, which is like breaking down and breaking up compacted soil, um, and things like squishing them together, breaking them up. And all of these are ways to make clay soils better because it has some disadvantages, and these can mitigate that. This can make it better. Okay, so these are just last two slides for today, but this will summarize and visualize like sand versus silt versus clay. Let's compare the particle sizes between these three types of soil. Let's look at sand, the close-up of sand. The particles are very large, right? Can everyone see this? The particle size is large, like this. And if you look at silt now, the second one, it has smaller, but it's medium particles. It's larger than clay particles, but are smaller than sand particles. So silt is in between, in the middle. What about clay? Clay is very compact. You can see like these layers forming, and there's almost no space in between, right? There's no like good big space between the particles. That's why, in terms of particle sizes, clay particle size is the smallest. Then silt is in the middle, and sand has the largest particle size. So you can see all of them in one here. Okay, looking at this last slide for today, summarizing everything. Here, look at sandy soil. If you look at sandy soil, it has a lot of pores inside. Pores means air spaces. So it is through this space in between particles that let water and air through. So that's what I meant by water filtration, what it means to have great water flow and filtration, good water drainage. Clay soil, on the other hand, have very small pores because they're so tightly packed. There's barely any space in between. So it doesn't let water through very well. It mostly absorbs them. So it has high water holding capacity and does not let water through very well. And here's a comparison on the right. For sand particles, it lets water through very easily. It's flowing very easily. Silt particles are somewhere in between. Some flows out, some are retained. But clay particles, all of them are being absorbed and retained. It does not let many through. So yeah, water drains quickly in sand soil because of the large air spaces. And clay soil has tiny particles that has high water holding capacity. So does this make sense for everyone? Um,
Yeah.
Yes. Okay. Yeah, that's great. So that will be the end for today's lesson. Yeah, today we covered a lot of topics like things like chemistry, finishing up BECE, science part. We looked at different filtration methods, different cycles, and finally we learned about agriculture a little bit. So next time we will be finishing up agriculture. And then in 2 weeks from today, we will be moving on to mathematics. So after we finish agriculture, we'll be moving on to mathematics. And yeah, I think that's all I had for today. Do you have any final questions before we end today? Any questions for me?
Question. You don't have any question. You know. Hello.
Yes, hello?
Hello.
Yes, can you hear me?
Okay. So next week you're going to finish the agriculture aspect, right?
Yes, that is right. And then we will move on
Hello.
to,
Okay.
yes, mathematics. Mhm.
Then the following week we'll start with mathematics.
Yes.
Okay. Okay. So next week we continue with agriculture. So please. All right.
Yeah, if you don't have any questions, then yeah, I think I'll see everyone next
Okay.
week then. Yeah.
Sure. See you. See you in next
Okay.
week.
Yeah, thank you
Have a
everyone, and yeah, bye.
thank you. Bye bye.
Bye everyone. Yeah,
Hey, bye bye.
bye.